Hey, welcome back, guys. Continuing chapter 1, where we've been working with expressions and equations. And we're still going to be working with equations in section 1.4, but we're going to be working with formulas and equations and how you rewrite them. And we're going to focus on the formula part of that in this particular video. I'm going to make another video for rewriting what are actually called literal equations. That's what this equation part will focus on. The goal here in this video is for you to rewrite a formula to find an indicated quantity, and you'll understand what I mean by that goal really quickly. Now, first of all, what is a formula? Well, a formula, you know, is just some kind of equation that relates two or more quantities. In this case, I've got a formula that you ought to recognize. It relates the temperature in degrees Fahrenheit to the temperature in degrees Celsius. And the way the formula is written right now, it makes it really easy to plug in a Celsius temperature to find out what the corresponding Fahrenheit temperature. And in fact, that's what this example is asking us to do. This is generally how you have used formulas in the past right here. I'm going to show you what's different in this section as we continue to our next example. All right, here it goes. It says use the formula F equals 9/5 C plus 32 to find the temperature in degrees Fahrenheit that is equivalent to 20 degrees Celsius. All right, well, it's great when you have a formula and the quantity that you're trying to find is the quantity that's by itself in the formula. In this case, F is by itself, and we're trying to find Fahrenheit. And all we're going to have to do to find the Fahrenheit temperature is simply substitute the Celsius temperature that's given to us in place of C in this formula as such. Well, you can see I took the Fahrenheit Celsius formula and I replaced Celsius with 20. One note, for whenever you're showing your work for a problem like this, anytime you use a formula, I want you to write down the formula that you're using first, and then you can show me the substitution that you made into the formula right below that. Remember, I never want more than two expressions on the same line of work. Well, one equation is two expressions, right? All right, so we're working our way downward. That's how we're going to keep everything nice and neat. All right, well, let's go ahead and do the work here. Only two steps. We've got to multiply 20 by 9/5 and then add 32 to the result. And so let's do the 9/5 times 20. First of all, we can do some canceling there because the 5 and the 20 are both divisible by 5, so let's make that a 1. Let's make that a 4. And then this becomes 9 times 4, which is 36. And then we'll do 36 plus 32. That's going to be 68. And then, of course, another thing you need to do is anytime you're working with some kind of problem where units are given and asked for, make sure that you write down your units in your answer. In this case, 68 represents the temperature in degrees Fahrenheit, and so we'll go ahead and put that right there, right? So you know how to use formulas. There you go. But what if we wanted to take the same formula and instead of finding a Fahrenheit temperature for a given Celsius temperature, I wanted to find a Celsius temperature for a given Fahrenheit temperature? Well, I'm going to do that right here in this example. It says solve that same formula for C and then find the temperature in degrees Celsius that is equivalent to 86 degrees Fahrenheit. Okay, now you will tell me this possibly, and you would not be incorrect. You would tell me that I can just plug in 86 for F and then solve that equation for C. And you would be absolutely right. That can get you the Celsius temperature that corresponds with 86 degrees Fahrenheit. Although often, when the quantity you're trying to find in a formula is not the one that's by itself, C is not the variable by itself in this formula, then it's often helpful to go ahead before you plug anything in and get that variable by itself first. Okay, I'll talk more about the advantages to that later on, but that's how we're going to work this out. We're first going to solve that equation for C. Now, don't worry about the fact that we've got two variables here. All we need to do is make sure that the term that has a C in it is the one that we isolate. You won't see the need for this in this formula so much as you will later on, but often the quantity you're trying to isolate, it's useful to kind of highlight that so you know that it's the one that you're trying to get by itself. All right, well, to isolate that C, we need to get every term that doesn't have a C to the opposite side of the equation, first of all. And so we're going to subtract 32 from both sides. Now, do you have any idea what F minus 32 is? No, because you don't know the value of F. And so, and don't tell me you use 86. We're going to come back to that. We're just going to write F minus 32 for right now equals 9/5 C plus 32. So that was subtract. Oh, sorry, not plus 32. because when we subtracted 32 from both sides, the purpose was to cancel out this 32 right there, so it is gone. Okay, and then the next thing that we're going to do is we're going to cancel out the coefficient. We're going to make this a 1c, and in order to cancel out that coefficient, we need to multiply by its reciprocal, both sides of the equation by its reciprocal. So we're going to multiply the left side of the equation by 5/9, and we'll multiply the right side of the equation by 5/9. All right, so on the left side, I'm just going to go ahead and group the f minus 32 in parentheses, and then write the 5/9. And on the right side, 5/9 times 9/5 is 1, because any number times its reciprocal is 1. And so those would cancel out, and you're going to get the c. So here's actually the first answer that I was looking for, or first response I was looking for in this problem. I wanted you to solve this formula for c. Here it is. Now, why did we want to leave this as an f right here? Well, what we can do now to find the temperature Celsius for the degrees Fahrenheit is plug in the 86, okay? But we could plug in any Fahrenheit temperature we wanted to, and it would be really quick and easy to get a Celsius temperature now. Whereas if we had plugged in the 86 right here and gotten an answer, well, we would have had to redo all this algebra right here every time we wanted to find a different Celsius temperature for a Fahrenheit temperature. All right, trust me, it's easier to get the variable by itself that you want first. Then let's substitute. All right, now this is a completely separate part of the problem. I'll come over to the side and do it. We'll substitute 86 for f. And then remember to follow your order of operations. You don't need to use the distributive property here because you can subtract 86 minus 32, even though you could use the distributive property. Now 86 minus 32 is going to be 54. Then we can do a little canceling there as well because 9 and 54 are both divisible by 9. So we'll get a 1 here and a 6 there respectively, and then we're left with 5 times 6. That's going to tell us that 30 is the answer. And of course the units for that are going to be degrees Celsius. Alright, so this is the focus for this particular lesson, is being able to take a formula such as this one and solve that formula for one of the variables that is not already by itself. Okay, now you might have 3 or 4 or 5 variables in there. It won't just be 2 every time like this formula has. Alright, but you'll want to isolate a formula for a certain variable and then be able to find out what the value of that quantity is based on other things. You'll see what I mean right here. All right, another formula we're going to work with. You've done this many times. You have used the base and the height of a triangle in order to find out what its area is. All right, now what we're going to do this time is we're going to solve that formula for the base, b, and then we're going to find the length of the base of a triangle that has the given measurements that you see down here, 72 square centimeters for an area, and a height of 8 centimeters. All right, you've used this formula many times to find the area of a triangle if you knew the base and the height. Now we're going to say if we know the area and the height, let's find the base. So let's do it again. I'm going to go ahead and highlight the variable that we're trying to get by itself. There are 3 variables here. We'll be done solving this equation whenever we've got the b alone or isolated. Now, we've got 2 things to get away from it. We've got to cancel out this 1/2, and we got to cancel out the height. Well, let's go ahead and cancel out the 1/2 first. Now, that's a coefficient, isn't it? And so what we can do is go ahead and multiply both sides by its reciprocal, which is 2, in order to cancel that out. And so if we multiply the left side by 2, we'll have 2a equals, and then of course 2 times 1/2 cancels, and we're left with b times h on the right side. And we're still trying to solve for b. Now, if you have the base times height, even though this h is written after the variable we're trying to solve for, we can still think of it as a coefficient because you could put that in front and make it hb just as well. And the reason why I say that is to help you realize that we're going to divide both sides by h in order to get that b by itself. Now, do you know what you get when you divide twice the area by the height? Who knows? We don't know the area of their height, at least not at this point in the problem. So we're just going to put 2a over h as a result of dividing the left side by h. And then the result of dividing the right side by h is that you've got b by itself. So that's the first thing we wanted to do, solve that formula for b. Now this formula would let you take any triangle, and given its area and height, you could quickly computate what the length of the base is. Compute is what I meant to say. Okay, let's go ahead and do that then with these two values for the area and the height. Okay, so you see I substituted the 72 for A and the 8 for the H. And I'm going to do a little canceling here, actually. Remember, you can always cancel out common factors between numerators and denominators within a fraction. And 8 and 72 are both divisible by 8, aren't they? So I can cancel this out. 8 goes into 72 9 times. And I can cancel out that and make it a 1. So the base is really just 2 times 9. And that looks like to the 9th power. That's not what I meant. Let me rewrite that. And of course, 2 times 9 is going to be 18. The length of that base is 18. Now, what are the units? Well, the area was given in square centimeters. The height was given in centimeters. Well, in order to get square centimeters for the area, both the base and the height need to be in centimeters as well. That's what this is in, is centimeters. Okay, one more problem we're going to do, kind of similar to this one, except I'm going to switch up the figure. We're going to use a trapezoid. And the formula for the area of a trapezoid is very similar, except that a trapezoid has two bases of different lengths, as opposed to a triangle that only has one base. Okay, so we're going to solve this formula that calculates the area of a trapezoid, and we're going to solve it for B1. And then we're going to find the unknown base length, which is going to be B1, of the trapezoid below that has the measurements here, an area of 130 square millimeters. The second base is 12 millimeters, and the height is 10 millimeters. Okay, well, let's work on solving that formula for B1 first. Now, sometimes you have to use a little bit of logic to be able to make this happen. We need to be able to isolate B1, so we need to get it away from the B2 and the 1/2 and the H. And you got to think about what order can you do that in. Well, right now, the B1 is trapped inside of these parentheses. And so we need to be able to get rid of the parentheses before we can isolate the B1 from the B2. We can't separate these two things yet. All right? What we're going to do is actually see if we can cancel out the 1/2 and the H first, and then that will make the parentheses irrelevant. Then we'll be able to get B1 by itself. Okay? Now you might suggest using the distributive property here, and you would not be incorrect, but this is going to end up being easier if you'll follow my suggestion, which would be basically the same two steps we did in the last thing. Let's cancel out the 1/2 to begin by multiplying both sides by 2. So we'll have a 2a on the left side, and the 1/2 goes away on the right. Like so. So we cancel out the 1/2 there. And now what we're going to do is we're going to cancel out the h. Now since that's h times this sum right there, we can cancel out the h by dividing both sides by h. So again, we're going to end up with a 2a over h on the left side. And since we cancel out everything outside of the parentheses here, we don't really need the parentheses anymore on the right side of the equation. And so now we've only got one more step to be able to get B1 by itself. We freed it from the parentheses. What we can do now is simply cancel out this other term, and when you're canceling out an entire term, you subtract or add, but in this case subtract, don't you? We're going to subtract B2 from both sides of the equation. So we're going to take this quantity on the left side of the equation and subtract B2 from it. Which you can just write exactly like this. You just write the 2a over h and then put minus B2. And then that equals B1. And we've satisfied the first part of this problem. We solved that area formula for the first base instead of the area. And now that we've got B1 by itself, it's really easy just to plug in the area, the base, the other base, and the height that's given to you in order to find out the value of B1, which is what we're doing now. All right, so we'll put 2 times 130 over the height, which is 10, and then we'll, after we figure out what that is, we'll be subtracting B2, which is 12. All right, we can do a little canceling here as we did in the previous example. The numbers are nice enough. They're not always going to be nice enough like this, but here they are. We know that 130 and 10 are both divisible by 10, so let's make that a 1. Let's make that a 13. And so then we have, let's do some mental math here, 2 times 13. Now that's going to be 26 over 1, still 26. And then 26 minus 12 is going to be 14. So that other base, B1, that was not given to you, ends up being 14. and it's in millimeters because the area is in square millimeters and the other linear dimensions were in millimeters. Okay, so now what you ought to be able to do is take any formula relating two or more quantities and solve that formula for a certain variable, such as B1 in this case. And then use that rearranged formula to find out, what that measurement is that you were just solving for based on other measurements. All right, thanks for your attention. Good luck with all the problems you'll do with this. See you in the next one.